Okay, good morning, guys. We are starting again with boosting. So today we are going to do light GPM. Now, light GPM is another boosting algorithm which is actually optimized to get better results, faster results. So I have already shared that with you. So let's see. So we know that gradient boosting is a machine learning technique and it can be used for regression or classification task. And this light GPM will be using for regression. So it gives you a predictive model. This gradient boosting gives you a predictive model in the form of an ensemble of weak prediction models. That is, it gives you an assembly of weak models, a collection of weak models, you can say, and they are typically called decision trees. Okay, so that is okay as far as theory is concerned. Now let's see what light GPM is. So LightGBM as a light gradient boosting model. It works. There are two basic techniques in LGBM. I'll be using LGBM, light gradient boosting model. So one is the Gauss, and the other is EFP. Gauss is one gradient-based one-sided sampling, and it is a modification of gradient boosting methods. And the focus here is on those training samples which results in large gradient. That means large gradient. When we say that, means they are weak um, le- learners, you can say, or elements, you can say, or you can say which have lesser cost attached to them or lesser weight attached to them, which are not very good learners. Okay, so this is what you get. And the other one is your EPF, that is called exclusive feature building. Okay, so exclusively feature is what is important actually. And when we say feature, basically it is not your facial features what we are talking about. Okay, in a human being you can see the features clearly. Okay, but in a data, what is a feature? Feature is actually the data itself. So people get confused that what the features are, but I can tell you features basically are what is stored in the data. So it is an integer data set, suppose. So whatever the values stored are integers, and for that I can give you an example of an image. I wish I could show you, but I will show you one day once I install MATLAB on this laptop. My other laptop has the MATLAB, but this one doesn't. So I'll install it and I'll show you, and you'll be able to understand what it is. So for now, you just have to imagine a graph paper. Okay. Now, if you draw a face on it, right, there will be certain blocks which will be left out, and certain uh, if you're just drawing a sketch, nothing else, you're not giving any facial features, and eyes, nose, ears, definitely you're making, and the lips you're making, and the chin and all is there. So outlines is, suppose you're making an outline on a graph paper. So there will be some stuff which is left out, and there will be like some squares which will be of more importance, right? So the features basically are your outlines. They are the main features. Okay. So, but when we talk about a computer, image is actually digitized. It is in digital form. Why I'm giving you this example? Because image is easy to understand. We all see images every day, but we don't see the numeric data everywhere, right? But for a system, an image is just a matrix only. It is just a matrix with numbers from and numbers are basically the color numbers 0 to 255, and then in between there are millions of colors between 0 and 255. It can be zero point 0.1 and also on, and there could be more RGBs and red, green, blue. We have three layered, or we just have a gray image, or we just have a black and white image. There are a lot of it to that. There are a lot of formats of images. the color images. But anyway, so these basically the outlines which are there on your graph, they're the more important features than which are left out. So image will be in a square shape. You must have seen when you click using your camera, your mobile or your camera, you see a square around the face. That square doesn't actually is not the outline of your face, but in it is something around it, right? So main features inside and rest are actually the features are there, but they are not important as far as face is concerned. So normally what we do is we dilate the image, and then we just remove the background, and whatever the outline we get, that inside that is the basic feature. So as far as feature in an image is concerned, this is what the feature is. But suppose we are talking about a numeric data. Let's say we talk about the weather data. This is again easy to understand. So we have day wise, week wise, month wise, and hourly data. Okay, so uh, we have a time based or a time based sampling. This is a time based basically. uh, we have different actually jargons which we use for these things, but anyway, I'll just tell you in very layman terms, so I will not be using that. It may create another confusion for you. Anyway, so whatever you have around that in the data, like we have in weather data, so the temperature, humidity, all these things form the data for an hour. Cloudy, shining, humid, or intensity of the wind intensity, and all. So you have all that. So this is hourly, weekly, sorry, hourly data, which could be daily, and then weekly, and then monthly. So this would be the feature of a weather of a place, right? So this number is a feature only. So whatever you have in data, that will be a feature. Now let's go back to stock exchange. Okay, let's go to not go back to let's go to stock exchange. In stock exchange, how a particular stock is behaving over the years, or over the months, or over the weeks, that particular values stored will be the features, right? In an audio, right, your frequency is the voice which is stored is the feature. Okay, so voice is again in integer form only, so it's not nothing like you have like integer are the numbers only, so it would be a float or a double value. And we have the bands also, and the frequency also. Sampling frequency is there. So your sampling frequency and all this data is again numeric data. You don't have to convert it also, because sound is actually digital, and you don't have to do anything with that. It will be straight linear form, and two-dimensional maybe, because if you have like a stereophonic voice, then we have two bands. Otherwise single band would be enough, right? Mono is single band, stereo is two band. Two band, when we say two band, that means two rows. Okay, so nothing like they are two different things. This is the same matrix with two rows or single row. If single row, it is mono. If there are two rows, it is stereo. Okay, stereo voice. So feature, when we say feature is just actually the numbers which are there in the data, right? So it is not something else like here. Human being, we have the facial features. Again, these facial features for my computer would be a number only, right? As I told you, I gave you an example of an image on a graph paper. You can see that when you draw, it will give you some values, numbers only. So that is your feature, right? Now, so we have this LightGBM uses GOS or EFB, And I've explained what GAUS is and EFB is. EFB is not required for now. I've just done with the GAUS. Okay, so gradient boosting, we already know what gradient boosting is. So the main features of LGBM models, there are 5 things. One is high accuracy and faster training speed. Then low memory utilization, that is also very important. And speed and memory, there are 2 things which are very important. And comparatively it is better accuracy, it achieves better accuracy than most of the algorithms as far as machine learning is concerned, like random forest and all. So it is better, and it can handle overfitting much better than other algorithms. And then we have a parallel learning support, like we have for the tensors and all. Parallel computing, it supports that also. And it is compatible with either the path, it's a big data or small data set. It doesn't make a difference to LightGBM, right? So anyway, so let's see the working. And first of all, we have to install it because it is not pre-installed. Hit install, we have a colon here. Okay, hit install, and LightGBM is in small. GBM, I hope I have spelled it correctly. LightGBM. Let's run it, and let's wait and see what happens. First time, it will take time. Okay, it is already there. Requirement already satisfied, so we don't have to. They may have installed it, or it is possible that they may have installed it earlier. Sidekit. Okay, Sidekit has LightGBM. That's okay. Fine, good enough. Now we are just creating a data set, so we will use a make classification. We'll call you have to create a data set, or you can actually use a CSV file also. But here we are using uh, the we're creating actually sklearn dot data set data sets learn dot data sets import and make classification. We'll be calling this function. Okay. And then we have to define the data set. We are defining it, and now we are creating x and y. We always do labels and data we have, and we have used make classification. I'll just copy it. This I'll be passing on the data, sorry, parameters to generate the data. Okay, so number of samples you can give. So number of samples is equal to, I can give a 1000. Then we have the features equal to 20, let's say. Then we have another informative. We have something called an informative. Number of informatives is equal to, it can be any number, but let's have 15 less than the number of features. And redundant is repetition. How many are redundant? Maximum 5. Number of redundant is equal to 5, and random state we can have, so that we can fix it. So I will give 1503.
Unknown caller.
1 minute. Okay. So we have make classification number of samples. Oh, I muted that. No, it's okay. Okay, nah? Yeah. Okay. X, Y, make classification number of samples 1000 and all we have given. Let me run it first and see if my syntax is okay. No, there's some issue. And make classification got an unexpected keyword n features. N features. Oh, I my spelling is wrong. As I told you, it is FEA. I miss some unredundant. I think I have misspelled that also. Redundant is okay. Redundant. Let me copy it. That is okay. Redundant is okay. Looks like. But let me copy it again. I think I misspelled that. Redundant. Oh, dent. I had written. Dent it is. Okay, that's fine. Okay, spellings can go wrong. No issues. We are not working on the spelling. Let's see the data. So we'll print that. Print x x dot shape and print y dot shape. Let's see what we have. 1000 by 20. Yeah, it is 1000 by 20 and labels are 1000. So we have the data and let's see what is there in the data. Print x. The labels can be numbers. Okay. This is the data we have. And print y. This is automatically generated data. You can use a CSV file also. So these are the labels 0 to between 0 and 1. That is binary we are giving. So this is a binary kind of data, 0 and 1. Okay. So let's make a prediction. Predict using LightGBM. So let's call the required modules first. So from we already have called the make classification. It's already there. Yeah. So what we need is just the classifier. So I just call from light GPM. Yeah, it is there. Light GPM. Import LGPM classifier. LGPM classifier. Okay, you can use a classifier. You can use regression. Whatever you want to use, you can use that. So we have to define the model or call the model. First of all, we have to define the model. Normally, we use sequential in case of deep learning, but here we have the classifier, so we have to use this. We have to call it. We have to define it using a round bracket. Now, you have to fit the model to the data set. We are not splitting it, in the entire data there. So let's see model dot fit as always x comma y. You can store it in a variable also. Now, to make a single prediction, we need our data. So let's have the rows. We have what 20. I have the data with me. You can have some other data also. I already had the data, so I've used the same data. Okay. So row we are doing. So for single prediction, what we are doing, we are going to now find the predicted value. So model dot fit, model dot predict, model dot predict, and in this case we have to pass on the row, but in square bracket. Okay, and you just have to print predict, and then predicted class we have to find, or we can actually put it like this, something like this. Let me run it. It has an error. I think it was giving me error earlier also. Let me correct it. Let me not check. That's okay. GPM classifier. Okay, there's something wrong here. Let me change it. Should be okay now. Model LGB classifier. Y is not defined because Y is small. Oh, I put it big. Sorry, it has to be small. Okay, so we have predicted class here. Should be the same. 0, 1 depends on the data we're generating. And since it is a random data, so it may vary. And if I change that to random, some other random state, let's see 7, the data will be different. I'll show you. You can see the predicted output here, and the output here it is 0. That is matching the 0 class. Let's make 7. The data generated will be little different. Yes, it is little different. Then we have to again do the same, and you can see that the predicted class is also now different. So it depends actually what random state you're using. If you're using the same random state, you can use the same also. So it will be fixed actually. So 1 you're getting for this 0.2994. Let's see if it is my single prediction only. It's a single prediction. Let's see the first value. You can see that the first value is something similar. 29299499949, yeah. And the predicted is 0.929949, same value, and the predicted class is 1. Earlier the class was 0 because it was matching the first one. Okay, so you can take out this data, and you can get it from there also. Let me see if I can do that. I can do it here. Hmm. This is text. I don't want text. I want code. Okay. We have X, and we have happens 0. Let's see. This is what you get from there if you're trying to extract the entire thing. I just want to extract the first. You can have something like this also. So it may be, it may change. Okay. So anyway, the predicted class, you can see this is matching with the first one. Yeah, this one. It is just returning, it may return something else. It happens. So it's a random state, the data may vary, data may change. If you want to get only one value, you can do that also. And if you want to have multiple, we can have the multiple also. So let's see. Now we have got this stuff, and let's create this data again. The data is already there, we don't have to create it. So what you can do, multiple classification also you can get. You can use now on the same data. Let's have regression. That was classification. Let's have the regression now. I just removed it. So from LightGBM, import LightGBM regressor. Earlier it was classifier. Rest is same. Testing data. I've just renamed it to test, and predict model.predict test and predict, and you can get the value. Let's run it. The classification, regression, whatever you want to do, you can do. and you can get this data. Okay, so you can do prediction like this or like that. So it depends again. And here the stuff may be different, the data could be different. And since it is regression, so let me create the data again. Let me create it again. Yeah, classification I have already called, so let me do that. To make regression we have, and LGBM regressor we have. We have to call it. I actually change that. Here you are. There's a lot of printing here. I'll just, what I'll do is I'll just take out the predicted values. Let's run it. This is what you get, the value. You're getting the predicted value like this. I can remove it from here. So you can use either classification, regression. For classification, you have the classification model, and for regression, you have to call regressor. To make regression and make classification, you have to generate the data, is if you want to, and then you have to call from LightGBM, you have to call LGBM regressor. So classification, regression, both we have here on LightGBM. So any of that you can use, and we have already seen what classification is and what regression is. But if we have any doubts, we can discuss it again. Now, let's have some cross validation and see how the ideal number of trees affect the performance. Okay, so let's have the data. I already have code, so I won't be typing it. It will take a little time. So I'll just put it. The data is already there. So we have from NumPy mean and standard deviation we have taken from sklearn dataset import make classification, then selection cross validation score to get the accuracy, then model selection is repeated state field fold, like k means this is a different one, and this model LightGBM model we have LGBM classifier, and then plot file. So we have functions here, get the data set. We are just creating the data set as we did earlier. Then we have to get the model. Model is equal to dictionary. Trees, we have 10, 50, how many trees? We are increasing the number of trees actually in classification. You can see that number of estimators is equal to n. We have not put it, we have just put it to default earlier. But when we are calling the model now, what we are doing is models, first, second, third, fourth, something like this. Number of trees, the model 10. LGM classifier will be number of estimators will be 10. For 50, it will be 50 and so on. So we are returning the model. So now the model is actually uh, either having number estimators to be 10, 50, 100, 500,000, 5,000. Now for evaluation, we have another one. We have a repeated state fold state stratified fold, sorry, K fold. K fold classification also we have K fold for evaluation we have. So we are using repeated state stratified K fold. Repeated stratified K fold. Number of states 10. Repeat 10 random state. We have fixed one. Now we can calculate the validation score model XY scoring accuracy and CVV is equal to CV job number of jobs. You can see that number of jobs already defined. So we are doing this stuff here. So you can have the data XY is a get data set. From the function we'll get the data set model. We already have the model results name list, and these are the two empty lists we have created, list results and the name, so that we can actually uh, display what happens when we increase the trees. Okay, so you can increase or decrease the trees, you can see that. So for name model models dot items for the evaluate model, then results dot append, we are appending the results to the list, then name of that append, appending the name, and then plotting and printing. That's one. It is same, but as before, classification as before, but here only number of trees are increasing or changing. We can say that. You can see here the output. You have the name, then mean score and standard deviation, standard score. Still working because we are plotting also. We have 5,000 also. So 5,000 will take little time. So 10, 50, 100, 500, 1,000, and then we have 5,000 also. Number of trees, if you are increasing, then definitely it will take more time. Let's see what happens now. Waiting. You have to wait little, not much, since LightGBM is fast. You will get faster results. It is fast and more accurate than the other boosting algorithms. Yeah, gradient boosting. Yeah, you can see that. 5,000 also is 0.28. You can see this. How it is behaving. This is the mean value. So for 10, it is actually giving a better result. So it is not necessary. It depends on the data actually. So it depends on the data. It's not necessary that you increase the trees and your accuracy will be better or your score would be better. It is it may result in overfitting, that is overdoing something. It is like over stuffing your tummy. You keep on eating, what happens? You will blast. You may not blast, but you won't be able to eat anything, and you will not be able to walk only if you are overstuffed. Okay, so even in a burger, if you overstuff it, it will spill out, right? So this is what overfitting is all about. So overfitting is doing something which is not required, which is extra. Okay, number of repeats, number of loops. If you have achieved the maximum optimum results in, let's say, in a fewer iterations, then if you keep on repeating, then what happens at one stage it will give you some errors, or the result, your accuracy would go down. Okay, so in this case, with this data you can see that with the 10 number of trees 10, the results are better. These are nothing but we are the functions, and we have put the trees to 10, 50, and so on. So if you decrease the trees, it may be you may get better results also, right? So it depends all on your data, what data you have. So it may vary, but you can experiment with the things and see. Okay, so I can actually decrease the number of trees also and see if we can get some better results, right? So let's have it. I can pass on from 1 to 10 and see what gives me better results. Anyway, let's see if we can get you some other stuff. Mhm. Let me show you. I have written a code where I've increased actually this the same code. The only difference is I've put it in a range actually. I'll just show you. I created a range of numbers here. Here. The model alleged classifier maximum depth is equal to I, number of levels is equal to 2 power I, 2 to power I, 2 square, 2 to power I anyway, whatever it is. So between 1 and 10, we have, let's run it. You can see 1, 2, 3, 4, it will come, and the score you can see. Mean score, we have the first is the mean, and the other is the standard deviation. How much it is deviating. 5,000. The accuracy has increased, but you can see this. It is not increased. It is 1,000. It's 100, 500. 500, the result had already achieved. At 500, your accuracy was like 0.93, 93%. You can see it is increasing with 1, 2, 3, 4, 10, 0.928. That means if I increase it further, I can increase it further. Let's say this to be 20. Till it does this, I'll have in decimals also the values. Just put it there. See, now it will increase. Number of trees will increase one by one. Little slow because I have increased the number of trees. So that's okay. You can see that there is a warning now. User warning. It's nothing. Oh, it is not saving actually. So let's save it manually. There's still a timeout warning. So you may get some errors. Okay, no, it's there. The value is there, but it is giving you warning. It's about timeout and all. It is not able to autosave, so that is a problem with the collab, not of the code. Oh, it is not of what we were doing. I'll just run the other code also. I'm checking this code, what we are doing here, and just run it. It won't run unless the first finishes. Here, the trees are like 0.0001, 0.001, 0.01, 0.1, and 1.0. There's a memory leak. This happens with collab sometimes. I was doing something yesterday and I put my code. It was running, and then after 5 hours, it gave me memory warning, then error, and then stopped. So my whole classification, I was doing some image classification using Python, and it just crashed after 5 hours. It's a long data set, big data set. It happens sometimes. We just put the data and just go around, finish our stuff, and when we come back and we see that okay, this is working now. It happens. We don't have supercomputers to do the job. We have to deal with what we have, the slower systems. Although this is the one I have using, the one I'm using is actually industrial, or it's a gaming laptop basically, and a little more advanced than normally we have. But then we do stuffs like that where we require. I can stop it. I think there's no point. Yeah. There's some error, right? It has given me it has given me some error. It is quite possible that, let's see. Yesterday also it was the same story. So collab does crash sometimes, but this is a small number of trees are smaller, so you don't have to worry about this. This is 0.001, 0.001, then 0.01, then zero point 0.1, and 1.0. Just checking actually. So if I give number of trees lesser, then at 1 the decrease is 0.9, 92%. You can see that it is 92%, 92.8. That's good enough. So it may increase to certain level, and then it may hold down. Okay, let's explore what we have here. Okay. So we have different uh, boosting types, like we have gradient boosting decision tree, GTBT. Dot we have, that is dropout meet a multiple additive regression tree. Then Gauss we have already seen. So how we use it, I'll just use one of that, and I already have the data, sorry, the code with me. I can use the same code, and I can actually have different functions along here with it. Oh, that. One was the same data, so it is the same. Now the type model, again dictionary, and type is dt dot and cos we use. So for t in types, one at a time we are passing. Now this is boosting type is t. Okay, we had given number of trees earlier. This is boosting type. So with the boosting type, change in boosting type, what happens? Let's see. On the same data set. So comparison is always drawn on the same data set. If the data set is different, then you cannot actually compare. With the GBDT, what we have is 0.925, that is 92.5%. With the dot, we have 91.2. With the cos, you have 91.8. 8. So you can see that GBDT works better on this data set. It is not necessary that it will always work this way. It depends all on the data set. So you can always check your data sets. You can put in a loop, pass on the data and models, and check if everything works fine or which one would work better. So you can put it in an iteration and check something like this, right? Okay, so this is what we have with the LightGBM. This is giving some error, but let me reduce that. I don't like errors. Let me reduce it to 11. One is left out. Let me run it again. Let's wait for a few seconds, few minutes rather. It shouldn't take much time. Now it is only up to 10. Number of trees, or you can give the boosting type also in the classifier. Okay, so one more. Yeah, done. So no point in having the errors. So you can use LightGBM, and LightGBM you can use with any data set, and I can show you with a real-time data set also. You can apply on any real-time data set to perform regression or classification, any of that. So in our first few lectures, we had seen what is regression, what is classification, and we had classified, we have put the algorithms, different algorithms in that also, which comes under regression, which comes under classification, what are the advantages, what are the disadvantages with a different algorithm. We have already done that, right? So you can have a look at that, and let me first share this with you. Okay, this is 16. Lot of
Hello, sir.
finding. Yeah, tell me.
Regarding the scrapping assignment,
Yeah. Tell me.
we are facing issue with the Amazon, sir.
Amazon. Okay, you can share the screenshots with me. I'll check
So,
it.
attribute errors are randomly popping off, sir. We are unable to
At
solve it.
attribute error because it is of the it may be because of the class. I'll check it. I'll let you
Yes,
know
sir.
what is the class. The
Okay,
class
sir.
actually
Thank you.
has the main class has to be seen first, right?
Yes, sir. I have seen it, sir, but unable to find
Uh,
it also. Even I tried a few times, sir. I'll send you the
uh-huh.
code, sir.
Yeah. No, you don't have to send me the code. I'll check it. No issues. Code is
Okay,
same.
sir.
Actually, what we have to do
Yes,
is we
sir.
have to change the
Change the
particular.
classes, sir.
Yeah,
Yes,
yeah.
sir.
But it happens actually. Amazon actually is little different.
Yes,
Okay.
sir.
That
Considering to Flipkart, it was different, sir.
Flipkart is very easy. Flipkart is easy. Actually, Flipkart is easy to hack also.
Okay.
People hack it easily, but Amazon has little different attributes. So I'll have to check it anyway. Even if you are able to do Flipkart stuff with mobile and laptops, you can share it with me. No issues. I won't mind.
Yes, sir. Yes, sir. I
And
was
you
able
can
to create
share.
the
Uh, and
CSV
you,
file, sir, but the
uh,
values are not coming, sir. I mean, we are
values
unable to find.
of what?
Uh,
Of Amazon or
yes,
Flipkart?
sir. Amazon, sir.
Amazon. Okay, you can share the codes with me. I'll check it.
Okay, sir.
Okay, and even if you are not able to get the values, doesn't matter. If as long
Okay.
as you get the values from Flipkart, because Amazon actually it updates also regularly.
Yes, sir.
And interestingly, my cousin is working there with Amazon in the development team in USA. I'll
Okay.
ask her what they have done. If I get through it, so my cousin is there. She's in the
Uh,
programming team. So they are doing the stuff and all. They maintain this AI and all, everything they maintain. So I'll ask her if they have changed the tags and all, and
yes,
they
sir.
keep changing.
Yes, sir. Even for the divisions, there are so many subdivisions. It was
Yeah. That
difficult to
is all.
find, sir.
Exactly. I'll find it. I'm used to HTML. I'll find it. Otherwise, I'll ask my cousin. She will tell me
Okay.
what they're
Okay.
using.
Okay,
Right.
sir.
So it
Thank you, sir.
happens. right? That is not an issue. Don't worry about that if you're not able to get. As long as you try, it's okay. It doesn't matter. You get, sometimes you get results, sometimes you don't get results. It's okay, right?
Okay.
But as long as
Thank
you
you, sir.
try, that's okay. I'll just share this with you. Okay, it's one. So let me stop this recording. It's not required. And then I believe 18th is a